Hi Carly, thanks for your question. I'll do my best to show you the steps that are missing because there are a lot of steps missing here, and I'm sure you'll catch on because you have great math skills. So also I'll mention that I think I have a 7 o'clock, but if you want to come in at 7:30, that's fine. I'll try to remember to mention that in my email back to you as well, okay? All right. So what we're going to do here is we're going to do a process called taking logs of both sides because that's what we do with trying to solve for exponents. You can use logs or longs, but logs are pretty customary. So 0.08 over 0.005 is 16. So just to simplify things, I'll write log of 16 there for that side. And then over here, what I can write is m log 0.4 over log 0.1, okay? And so if I do that, then using the laws of logarithms, when we're dividing logs with the same base, it's the same as subtracting them. So just like with, the exponent laws, if we're multiplying exponents with the same base, like, I don't know, like 5 cubed times 5 to the 4th, we keep the base the same and add the exponents. If we were dividing, I should have started with dividing. We keep the base the same and subtract the exponents. So this rule, inside out, applies to logs. So here we were dividing the powers, and so we subtracted the exponents. And so here we have divided the logs, which means we were subtracting them originally. And so log 16 equals m times log 0.4 minus log, I've got to squeeze it in here, 0.1, okay? So if you work that out on a calculator, you have to grab the calculator at this point to get those logs. These are both base 10 logs because we took the log. If you work that out, I think you get something close to 0.6, 0.62602, something like that. Okay, so all you're doing here is just putting in your calculator log 0.4 equals, and then minus log 0.1 equals, and then it'll give you this value here, okay? And so to solve for m, we're just going to solve the equation now by taking log of 16, dividing by 0.60021, and that should give you 1.99999, which gets rounded off to 2. So I just want to go back for a minute because I didn't explain that law very well. If you see logs, let's say we had something like this. Something like that, okay, as an equation, then both of these logs have a base of 10, which we don't have to write because everybody knows, just like when you don't see a base, it's got to be 10. So if they have the same base, then the rule of logs is that we can keep the same base and we can divide these parts, okay? And so what that allows us to do then is put it in exponential form because we've only got the 3 components. So we would take 10 as the base, 2 as the exponent, and it would be equal to that, and then that means we could solve the equation from there, okay? So what we did up here was sort of, we started at the end, we started at this point, and we kind of said, okay, well, where that came from was that originally we must have been subtracting the logs with the same base, and so we kind of worked backwards for what we would normally do with a law of logarithms, but I just wanted to explain that better, what that law does with the subtracting and dividing part of it. And that's the key to being able to solve for this, and he left all that out, well, sort of left all that out in the steps that he showed. So hopefully that'll help explain what he was doing there so that you could do that again if you needed to. And again, if you need to come in Thursday, I'll try to remember that in my email as well. I don't have a 7:30 appointment open on the schedule, but I can certainly book you in if you want to tell me that you want to come in at 7:30. Okay.